have a square one with some, do I have a square one? With y equals square root of x. No, I don't. Does anybody have a square one with y? Okay, so we go. Okay, so this is what Aditi has. The base is the y equals square root of x. Now, all of you guys have this. There's only two that we're doing. But what she did was she put squares all in them, okay? Now, there are only 10 squares here, but what you have to imagine is I really wanted you to cut out an infinite number of squares. We just didn't have time, okay? But there's an infinite number of squares here. So you can imagine the model. Does that make sense? Okay? So this is kind of like, I don't know what it is, a picture of, I don't know, a square armadillo. Okay, you know what I mean? We're trying to find the volume of him, okay? And how do you find the volume of him? Okay, well actually, let me borrow this again. How would I do this? I think what I would do is I would just take out one volume, and I would add them all together. Would that make sense? Okay, I want to take out one volume. So if I could just find the volume of the square, well, isn't the volume of the square really just the area of the square times the thickness of the square, and the thickness would be dx, right? It's a dx thickness, okay? So if you look at the problem says find the volume when the base of the solid is bounded by y equals square root of x equals 25, and the x-axis. So x equals 25 is right here. Here's the x-axis. Here's y equals square root of x, okay? And it says make the cross-sectional areas perpendicular to the x-axis. So it's coming down like this, all right? So these thicknesses are dx thicknesses, all right? And so this area, this volume is the area of the square times dx. And then what I'm going to do is I'm going to add all the volumes together. Does that make sense? Add them all together from 0 to 25. That will be my total volume. You guys good with that? Okay. So, sorry, I don't have to put that together. Okay, so this square here, see if this makes sense. I've got this. This is what her picture looks like. Okay, this is y equals square root of x. Down here you have y equals 0. Here it's y equals 25. Okay, and she's got a whole bunch of squares coming down here. Everywhere there's a line. Okay, an infinite number really. Okay, if I take one of these squares out, okay, what would the length of this square be? What would one side of the square be? Let's think about it. Do you agree one side would just be y minus y? Do you agree with that? I mean, it would vary, but any one would be y minus y. Do you agree with that? Okay. What is the length of this y minus y? You guys okay with that? It'd be square root of x minus 0. Everybody good so far? Okay. Well, if one side is square root of x, what's going to be the area of the square? Wouldn't that be s squared, which would just be x? You agree with that? It'd be square root of x times square root of x, right? Which would just be x, okay? If this area of the square root is x, what would the volume of one of these squares be? Do you see that it would be x times the thickness, okay? I don't want the volume of just one skinny little square. I want the volume of this whole thing. So I'm going to sum them all up. Does that make sense? I'm going to add them all up, okay? And so it becomes an integral, okay? And this is an x. So what x do I start adding? What is this x value here? 0. When do I stop adding all my volumes? 25. And there it is. That's the formula for volume, okay? With a known base of, this base here, y equals square root of x, y equals 0, y equals 25, with squares perpendicular to the x-axis. Okay? Pretty easy, right? So I'll just tell you guys that this answer is going to be from 0 to 25. If you do this, it'll be 625 over 2. Okay? But I'm not going to solve all of them for you. I just want to set these up. All right, if we look at the equilateral triangle, we're going to do the same thing. Okay? We have the same base. Okay, so some of you guys have this base. And let me see if I have one of these here. I don't. Does anybody have a y equals square root of x with equilateral triangles? Okay, so Kevin does. All right, so let's go take a look at Kevin's. All right, what I want to do is I want to find the volume of this thing. Okay, so remember there's an infinite number of triangles here. Refugee camp. Okay, so we're going to find the volume of that. Okay, so guys, take out one triangle. I'm going to get the volume of one triangle and then add them all up. Does that make sense? So think about this. It's an equilateral triangle. Every side is the same. Do you agree?
Yes.
Okay. What's one side going to be? What's the length of one side going to be? Square root of x. You guys see that? So we're going to need a formula for an equilateral triangle if you know one side. Do you know that formula? S squared square root of 3 times over 4. Okay? One side, you told me is square root of x. You agree with that? Right? Okay. The area of this triangle is s squared square root of 3 over 4. You're going to have to memorize that, guys. That is the formula for an equilateral triangle. You can do 1/2 BH, but the thing is, you're going to have to do a 30, 60, 90. Does that make sense to figure out the height? So I don't know the height, but this is way easier if you don't know the height. Okay? If I know my s is square root of x, what's s squared then? X. So there's the area for your triangle. Okay? If that's the area for your triangle, your flat triangle, what's the volume for that flat triangle? You just multiply it by dx. Does that make sense? It's thickness of dx. It's an infinitesimal thickness, okay? So it's x squared root of 3, 4 dx, okay? That's the volume of one of those skinny little triangles. That's one volume. I don't want just one volume, right? I want that whole refugee camp. I want that whole thing. Does that make sense? Okay? So that whole volume, one volume is this x squared root of 3 or 4 times dx. But the whole thing will go from, you guys see it, 0 to 25. Okay, so the limits actually turn out to be the same. And this will be from 0 to 25. Remember, this is an x dx, so it's an x limits. All right. All I really did, if this makes any sense, is as soon as I found what A is, that area, I plugged it into this formula. See, that was x dx here, right? As soon as I figured out what this area is, this formula was x squared root of 3 over 4, I plugged it right into this formula. Does that make sense? That's really what I did. Okay. All right, let's do it for a semicircle. Okay. If you look at a semicircle, okay, this semicircle, this right here, oh, actually, it's not S anymore. This is what part of the semicircle would this be? Yeah, it's a diameter. So I've got that up here. This one would be the real armadillo. Okay. We're going to find the volume of an armadillo, okay, with no head, okay? And if you pull out one of these, do you agree with me that the diameter is square root of x? Do you guys see where I'm getting it from? Okay, so the diameter is square root of x, but what I need to know, though, is I need to figure out the area of this thing. Then I multiply by dx, and that's the volume of one of these things, okay? So let's go ahead and figure out the area of one of these things. Now, the area of a semicircle, degree is pi r squared over 2. Okay? I've taught this for many years, and I just want to tell you to memorize pi d squared over 8 for a semicircle. Okay? It's not that you can't do it with pi r squared over 2, but this part right here, you'll have to divide this by 2, and you'll end up with a fraction in a fraction, and it turns out really bad. Okay? And students have trouble with this. I would say every time I've done it I did it for 2 years, teaching pi r squared, and I'd have like 50% of the class miss it. And I changed it to just memorize d squared. Don't even memorize this, okay? And almost 100% get it right, okay? So pi d squared over 8. I'll say just memorize that. If you're not sure where it comes from, go into a dark closet. No, turn on the light. Go into a closet, turn on the light, say r is equal to d over 2, and you'll get this eventually, okay? So what we're going to do is we're going to use this formula for a semicircle. Guys, if d is equal to square root of x, what's d squared going to be? X. So this is really just pi x over 8. Okay. Once you get the area for that cross section, okay, all you do is plug it into this formula basically. Okay. So my formula is pi x over 8. You'll just plug it right here where it says area. Multiply by dx, get the integral. Okay. And this is an x, dx. So these limits need to be x numbers. Okay. Then you go over here and you say, I don't want the formula for just the volume of one semicircle. I want the formula for all of them. I want to sum them all up from what's the lowest x, guys? 0 to what's the highest x value here? 25, okay? And if you do that, you'll get the answer here, all right? So I'll leave that for you guys, and I want to move over to the right side. We're gonna do dy. Okay, so dy, we're doing a different problem. This problem here is a y equals x squared problem. And I think they bounded by, was it x equals 4 and y equals 0, right? I think it's on your paper, right? What we're going to do is we're going to get this as the known base. And probably about 50% of you guys got this foam board, okay? And you guys need to know that this is a, oh, wait, this is not right. Thank you. It's an x equals y squared. Okay, so it's a y squared problem. So what kind of figure is it? Parabola, right parabola, right? And it's a left-right parabola because it's a y squared, look left and right. And you've got this parabola here. You've got an x equals 4. And what you have is, they say, lay your cross sections perpendicular to the y-axis, okay? Now, I need to make this clear to you. Yesterday, when you did areas, you chose if you wanted to do a dx dy. Does that make sense? You could choose the easier one. It didn't matter, except for like number 6 and number 10, where it said you had to use dx or dy, okay? And you chose the easiest one. On your test, you can choose the easiest way to do it. Does that make sense? But when you get to volumes, you cannot choose anymore. They choose for you. So if the problem says perpendicular to the x-axis, it's a dx problem. You guys good with that? If the problem says perpendicular to the y-axis, it's a dy problem. Okay, now you don't choose anymore, and that's actually kind of nice because then you know what to do. And so this formula is going to be the area of the square times dy. All right, the integral of that. So let's go ahead and get this square. So what I'm going to do is I'm going to lay squares perpendicular to the y-axis in here. And actually, before I begin, can I get this intercept right here? What do you think these points are here? This point here, because this is x equals 4, right? This point here is 4 comma the square root of x. So is it negative 2, right? And then this up here is 4 comma 2. You guys okay with that? Those are the intersecting points for x equals y squared and x equals 4. If you're not sure I did it, I just put 4 right here and then solve for my y. So I got positive and minus 2, okay, for the y. All right, so then what I want to do is I'm going to pull a square out of this. So does anybody have this foam board, the x equals y squared foam board? Oh, right here. Right here. Okay. Okay, you guys good that this is the x equals y squared foam board? Okay, with squares. You agree if I can get the volume of one of these squares, okay, I get the volume of one of these squares, I just integrate, I just add all these volumes together, I'll get the total volume here, okay? What's the volume of one of these squares? Isn't that just the area of this square times the thickness of this square? Okay, the thickness of this square changes though. What's the thickness of this square? dy. Do you see that? And what's the area of this square going to be? Remember, this square, the length of this square is right here. Oh, looky here. The length of this square is now not y minus y anymore. You guys see it? It's going to be what? X minus x. You see it? It's going to be the right minus the left. It's always the right minus the left if you want to get a positive area. Okay? So the length of this, so that's going to be s. Oops. That's going to be s is equal to the x minus the x. So are you okay? Are you with me if I say it's 4 minus y squared? You're with me on that? Okay. So what is the area of the square going to be? If this side, if one side is 4 minus y squared, what's the area going to be? That. Really ugly. You guys good with that? It's just a whole quantity squared. That's the area. And then what we're going to do is we don't want the area, actually. We want the volume of one of those squares. So the volume of one of these squares, okay, so the volume of just one squared will be this times the thickness. And you guys told me the thickness was dy, right? This is a dy thickness now, okay? And so what you want to do is, actually, I don't want the volume of just one square. I want the volume of all of the squares, okay? So you're going to sum that up. You're going to take the limit as delta x goes to 0. So that's going to be an integral. If this is a y, okay, you want to add up every single square here, okay? What's the lowest y value now? Be careful, it's not x value. What's the lowest y value now? Negative 2. What's the highest y value? 2. You guys good with that? And that's going to be your setup. I'm not going to integrate for you. That'll just be your setup. You'll have your calculator. Okay? Let's do an equilateral triangle. Okay, does anybody have a y equals x squared with an equilateral triangle? Anybody? Nobody? Oh, it's right here. Okay, good. Okay, x equals y squared equilateral triangle. Okay, make sure you understand this. What's the thickness of each of these equilateral triangles going to be? The dx thickness or dy thickness? Do you see why it's a dy thickness? Okay. If I take one out, okay, what's one side going to be? The length of one side. If I take one out, is it y minus y or is it x minus x? You see, one side is now x minus x. Okay. So let's get one side of this equilateral triangle. Okay. It's the same picture. It's just actually the same picture. It's now you have triangles lying here instead. All right. One side is going to be x minus x, so it actually turns out to be also 4 minus y squared. Okay. What's the area of this triangle going to be? Yeah. 4 minus y squared squared times the square root of 3 over 4. You'll have to memorize that formula. Okay? And then you take this area, and all you do is you plug it into this formula right here. Okay? So this is going to be the integral of 4 minus y squared quantity squared square root of 3 over 4 dy. You see how easy it is? I mean, we're doing the same thing each time. The hard part is trying to find the area of the cross section. If this is a dy problem, what's my lowest y value? -2. What's my highest y value? 2. Are you getting the hang of this? Let's do a semicircle. Okay, so I'm going to do the same thing, but now I'm going to put semicircles there. Does anybody have one with semicircle? Okay, so same thing, okay. X equals y squared. I'm going to pull one semicircle out. I'm going to get the volume of this semicircle. But do you agree the volume of the semicircle is really just the area of the semicircle times dy? Do you agree? Now here's the tricky part. What length am I looking at now, though? Am I looking at this side length? You see it's now a diameter. Is everybody good with that? Okay, so the diameter is going to be x minus x. Is everybody good with that? Okay, so let me go ahead and get this side value up here for this semicircle. This diameter is actually x minus x, which was 4 minus y squared. What's the area of the semicircle going to be? Pi d squared over 8, which is pi times 4 minus y squared squared over 8. What's the volume of all of these semicircles put together going to be? The integral of the area times what? dy. You guys see how easy this is? So it's very logical, okay? So now if I have a y here, what are my limits going to be here? -2 to 2. You guys good with that? Okay, so that's how you do these problems. I'd like to look at well, actually, I need to show you guys some formulas. So these formulas are formulas you need to know. Okay, you need to know the formulas of, and these are pretty easy, rectangle, square. Sometimes if it's a right triangle, if you know the height, you'll use BH over 2. If it's an equilateral triangle, you'll want to use this. Semicircle, you would use this. Guys, if it's a quarter circle, you will go back to radius. Okay, does that make sense? Because think about if you put a quarter circle, it's not a diameter length anymore. Does that make sense? It's going to be radius, okay? And then trapezoid, there's a formula there, okay? I'd like to look at number 2 on your homework with you. So go ahead, pull that out. And number 2, and actually 1 through 8, you're using the same foam base on 1 through 8. So it should be pretty easy. I'll go ahead and set it up with you guys. You have a y equals x squared. You have an x equals 9. And I don't know what else you have. Okay. Oh, well, that's all you have, sorry. Y equals x squared. Is it a y equals x squared? Oh, it's a y squared equals x. Okay. So that's an x equals y squared. So that's a y scared parabola, right? If you're y you scared, look left and right. It's a positive. So we're going to draw it like that. X equals 9 looks like this. Okay. And you're going to use this foam base for all of problems 1 through 8, and then you'll draw some new foam bases for the subsequent problems. So if I put rectangular cross sections of height 2 perpendicular to the x-axis, so here I go. I'm going perpendicular to, this is my region. Okay, maybe I should highlight it. This is kind of why it's important to highlight it, because you want to make sure you fill in your whole region. So there's your region, right? You're going to put in rectangles perpendicular to this region. If you can imagine, rectangles coming out of the board. Everybody good with that? All right. I'm going to pull one of these rectangles out, okay? This length here is this length here. Is everybody good with that? What's the height of each of these rectangles? What does number 2 say the height of each one of these rectangles is? 2, right? That's what it says. So every rectangle has a height of 2. What's the length of every single one of these rectangles? Well, let me pull it out for you. What is the length of a line that looks like this? Y minus y. What's this top y up here? You guys okay with that? What's this bottom y down here? All right, so what's this length going to be? Wouldn't it be the top y minus the bottom y? Right? So this is really the same as 2 square root of x. Is everybody good with that? So what's the area of this rectangle going to be, of one of these rectangles? What's the area going to be? 4 square root of x. Okay? And then you just plug into the formula. As soon as you get the cross section, you know the formula is a times, dx or dy. Is this a dx problem or a dy problem? Dx, okay? Because they said cross sections perpendicular to the x-axis, okay? If you just imagine, these are like little Riemann sums, right? So that's a dx problem. So this would be a dx, and you just plug it. This is a volume formula. So this is volume is equal to 4 square root of x dx, all right? If this is an x, then these limits must be x's, okay? You go back to your foam board, your region. What's the smallest x on this yellow highlighted region? What's your biggest x on this yellow highlighted region? Oh, I was going to say something else, but you're right, 9, okay? So that is your setup. And then you guys can do this in a calculator or by hand, whatever floats your boat. Okay, you guys feel semi-comfortable with this? All right, so 1 through, guys, go ahead and take apart your stuff too, if you don't want it. 1 through 8, you'll use the same picture, and the other ones you have to draw new pictures. Okay, 14, 15, and 16.